Okay, good morning, good evening, everyone. So we will start with provisioning of the infrastructure, and I have Amit with me. So we will be looking in that how we can provision the infrastructure together, and we'll do this collab project workshop with the TF module. So we'll use the Terraform and Terragrunt approach, and using the GitHub Actions and GitHub workflows, we'll provision the things. So this is a SkillUpWithSachin GitHub repository, and let's try to spin up the project. So let's create a repo here. Meanwhile, good morning, good evening, Amit. Now we'll give this repo the name as TF module AWS infra. Okay, and following the standard, we give that this repository will be used to provision the resources. Okay. And let's just create a repository. Now, once we have created a repository, definitely we need to clone this. Now, this is my repository. I'll just do cd documents, and I will create a folder name as SkillUpWithSachin -code, and we'll go into that. Now I will do the git clone so that I have the repository with me. Now we have this plain empty repository. Okay. We need to definitely, create the code structures and the things here. So for that, we have to follow a certain standards, certain practices and things. Now, definitely we need to create the EKS repository, right? We need to create the EKS modules and things. We will be also writing the things with respect to the GitHub actions and the things. But let's see if we create a EKS module, right? So we'll have EKS and we have to create the modules in that. So we'll create the EKS repository. And in this repository, we'll have another folder known as modules. Now in this, we'll have a files, right? Data.tf, that is my Terraform file. I will have, let's say, locals.tf. I will have variables.tf. I will have versions.tf. And I will have a main.tf, or we can name it as eks.tf, which will spin up everything. Now, based on this, right, based on this and based on the Terragrunt module, we also have to create a folder name as environment, means where we have to deploy. So we have created a folder name as environment, right? In fact, we'll rename it to environments. Now, definitely in this environment, we'll have a different folders. For example, you can again create dev folder, right? You can again create prod folder, and you can again create, let's say, a stage folder, right? Stage folder. So yes, you will have a definitely different things. Now, to deploy this via the GitHub actions, we will have to create a GitHub actions folder, and we'll write .github. And in that .github actions, let's say we will have the workflows. So we'll have to create a folder known as workflows. So far we are good, Mohit?
Yeah, Sachin.
Yeah. So basically, yeah, we are good here. We are basically good with this. Now our main file is this EKS modules, right? Where we have to write everything and put up everything. Since we saw, in our session that for creating any service, for spinning up any service, you need to have a modules, right? You need to put the modules first of all. So we need to we need to talk here which module. We need to talk here on the EKS module. So let's search in the Google, for the EKS module. So if we search for EKS modules, Terraform, so you will see here that this is your entire EKS Terraform module, right? Where you are calling a module EKS, right? You're giving the source, you're giving the name, version of the Kubernetes which you want. You want to tell that if the public access of endpoint is going to true or not, right? You want to tell that if the cluster can create admin permissions, admin groups and or not, right? It can have a compute configs, that is the node groups and things, what kind of things, what would be the VPC ID, what will be the tags and other things, right? So like this, we will have to create the different configurations, entire configuration for the EKS we have to create, right? Which will create a control plane, node group and all the details. So you have to spin up a node group also. So you have to write all these things, right? Okay. We also have to create a cluster access entries. So we have to give access entries and these things too. Cool. So let's start with the module, right? That okay, we have to bring up the module and in the sense we'll copy that from here and we'll paste it here. Where like okay, we have a module, right, with the EKS where like we have this is the source and these are the versions we're gonna use, and we'll have this provider versions. Now the first is that we want to pass the cluster name, right? Now as we want to pass the cluster name, so now you see as we are passing a cluster name, right? So we are just giving cluster name is equal to var dot cluster name. Now as we are giving cluster name is equal to var dot cluster name, it looks like that why I'm giving var dot cluster name. I can give here cluster name like this also, SkillUpWithSachin hyphen EKS. But I want to variabilize it, right? I want to make sure that the cluster names are variabilized, right? It shouldn't be in the main file. We can change it from the files later on, right? Then I have to use the cluster version, that what kind of EKS version it will be, right? So here I can give that name as var.k8 underscore version. Okay. Now I want that a cluster should have the public access or not. So there would be certain clusters which are in the private mode only. So I can give that private or public access as true or false. So we'll give that also. I want to give the cluster service IPv4, and what is the IPv4 range. Okay. I want to ensure that it creates the cluster security group on its own or not. So I'll variabilize all these components and I will manage the things, with respect to some more settings here. Now, while we set up Kubernetes, right, we do have a cluster add-ons, right? We do have the core DNS, kubeproxy, and you have the VPC CNI, you have the EBS CSI driver and other things. You also need to pass the VPC ID, you also need to pass the subnet IDs and other things. So we'll pass all those things again via this mechanism where we are going to define the cluster add-ons, that okay, have a core DNS as an add-on, put the replica count as 2, kubeproxy, right, install the EBS CSI driver, install snapshot controller, install VPC CNI plugin and other things. So these are something which will be responsible for our projects. Now then we wanna go ahead and we're gonna create some node groups, right? So we have to create some node groups which will basically help us to set up the node groups. So if we go here, right, we see this, okay, EKS manage node groups. We have this local node group, we are gonna do authentication mode to this. We're gonna create the disk size of this. We're gonna say create an instance of C6A S large and with the AL 2023, and we say that mm, minimum one, desired one, and max one nodes can be there. Okay, and we have given the to the node group, basically we have given this EBS CSI driver policy IAM role, which whenever we create a uh, node, so that is going to be there. Now this is basically our configuration, right? This is going to be our configuration which we have defined. Now we have to put some conditions in data.tf so that it can have the data. It can fetch, your availability zone, your current caller identity, region, and other things. And likewise, I have to also get the VPC setup, right? So for the VPC setup, for now, I can write data underscore AWS VPC, right? So this will be my VPC module I will be calling, and I can set this. Now I can filter the VPC name, right? In the ID. Basically, let's say I can filter this based on the tag name as name. Okay. And I can give some values to that. So that I have to check again that what is in the default configuration. However, like this, I need to search for the subnets, right? So I need to search for the private subnets, I need to search for the public subnets or whatsoever it is. So like this, I need to filter for the public and the private subnets too. So I'm gonna filter here my subnets, right? And I will write this way that okay, this is my private subnet, and if I want to give the public subnets too, I can give the public subnets. But that doesn't matter. That's not a big deal for now, right? Now the point is that okay, this I have defined the subnet configuration. This I have defined these things. Now I've defined some of the uh, variables, right, and the other things that okay, that what some of the local configuration I have to define. For example, I will be defining that okay, how my node group should be. What should be the name of node group? So I have defined that okay, this can be my name of the node group where like it will format into whatever the cluster name is there, -ng-1, right? And availability zone, you should take 2 to 3 only as per EKS configuration. So it is going to give that. And then this is the EBS configuration that uses EBS value of type GP3. It should be encrypted and these things. So these are basic configuration which we put for the uh, node groups and all. Now, remember we also talked that yesterday that we have to give the provider details, right? So that is where this versions.tf is there, where I have said that use the AWS provider and use this particular version of the same, right? So use this particular version for a particular AWS provider. Now comes the variable part. Remember we have given var.cluster name, var. This. So we define that okay, variable. The variable was the first variable we have given this cluster name. So you will give here as a cluster name, you will give the type as a string, description, you have given the K8s version, you have given the version of K8s to be set up, right? You have also created the cluster endpoint public access that okay, whether the public access should be there or not. So let's say we have made false if you want to spin up some private cluster. So we have given this, right? Now, we also have to give the cluster service IPv4 CIDR range. This is a range which by default AWS provides. So, if you look for here, right, this range, cluster CIDR Kubernetes, right? And let's say you see that, okay, how do you find this cluster and the service CIDR for the Kubernetes? So, it's, you say that you need to basically um, So you see, within one of the following private IP address blocks means you should use either of this. Okay, this is the service IPv4 CIDR, which is provided by the Kubernetes itself. That's the reason like we are using in the similar range. Here you will also able to find this range also. So you will find like all the ranges which are being defined, okay, in the other stuff, and you can use those things. Okay, whatever the thing there. See, this is the one we have used, right? The /16, right? This is the one we are using, 172.20.0.0.16, and this is the one we have here. Okay, in the Kubernetes network config response. So this we have picked up from here. Now we have this variable defined for the cluster service IPv4 idea, right? We have said that okay, use this, and definitely we will have some more. You will have a node group configurations. You will have the create cluster security group, node security group, and other things. So all those variables we have templatized here. So means we have a variable.tf ready, we have versions.tf ready, we have locals ready, EKS.tf ready, and data.tf ready. Good. We have yet not defined this part, the VPC part and stuff. And in the EKS, we also have to define some of the access entries part, right? So that is still not complete. But before that, let's say we have the environments folder where we have defined dev, prod, and stage. For now, let's say we have to spin up a cluster in a dev. Now, this is my dev, right? In dev, I have to create a cluster, for example, known as SkillUpWithSachin -EKS demo. Okay. Now, this is a cluster which you have to create. So you can create a folder of the cluster name, whatever you want to create. And then you start writing the Terragrunt.scl. Basically, this is there now. You will have the Terragrunt.scl, which will basically call this thing, which will invoke your Terraform. How you will include the root means you will include this root definition of the cluster, right? You will say that read all the account related variables from this Terragrunt config. You find the account.scl file, right? Means we will have the account.scl file is stored at the dev level. Okay, we'll have one account.scl file. Okay, this will be stored at this level. Now this account.scl file, let's say we will have the locals and we have to define account name. Okay, so whatever the name of the account will be there, you can define that, right? You have to write the account ID. There will be the ID for each account. You can put that, right? You have to put the AWS region. So example here, AWS region will be this. One minute. So this is going to be my account.scl, basically, which will have all the account related variables. Okay. Now, more than that, you also have to certain times define. So in this Terragrunt.scl, it in this Terragrunt.scl, we have defined that okay, read the account variables from here, read the root part from here, and read my Terraform related code from here so that it can apply the things, right? Now, with this, we also have to pass the cluster details. So now there is one good thing here which we do is that we manage all the cluster related files, the configurations at this Terragrunt. Means you don't have to make the changes every time there, right? You can just manage the cluster related changes from here itself. So let's say this is a cluster name we are going to give. We are going to give the node groups we are going to give the node groups config, and we will define that, okay, this is going to be my node groups config. And let's say my node group config will be this EKS demo ng-1 based on the format we are following, right? And then we'll have the instance type, the disk size, and everything we want to put up. Let's say we will have the instance type as this. This will be my minimum node group size. This will be my maximum node group size, right? Then I will have a desired size, and I will have a disk size, right? All of these can be part of this. Now I need to define my subnet IDs, because I need to tag to the subnet IDs that these are the subnet IDs you want to pick this up. And also I have to give the IAM role, which I'm going to ask them to create it, right? So in the IAM role, we are going to create the where.cluster other service cluster name hyphen node role. So I will pick up this cluster name, and I will define this as a hyphen node role, right? This is going to my IAM role name. This will complete my terragrunt.scl. Okay. Now there is one more thing, you need to define the Terraform.version also at a root level, because that has to be for the GitHub related stuff, that which Terraform version you want to put up. And as you are going to use the Terragrunt.version, so you're going to define this Terragrunt.version 2. So you will say that, okay, dot Terragrunt-version will be this file, right? Now, as I said, right, that you don't want to, yesterday, like I was talking, right, that you will have a .git ignore file, right, where you're gonna write that, okay, what all things you don't want, like TF state we don't want to add into the Git, right? Remember a bit that we have talked about that, right, man? The
Yes.
TF state and other thing. So all the local directories with Terraform will create any TF state, all this, any crash logs, TF vars files, anything like this will be part of this my Git ignore, that it will be not in the Git. It would all be there. Okay. Now, this way my entire stuff will be created. Now, the very first thing I need to do is that I need to format this, right? So I will go to the CD EKS repository, and I will first of all check whether I do have Terraform or not. So, okay, I don't see the, okay, my spelling is wrong. Okay, so it says I do have Terraform version 1.5.7. That is good. So now I will do Terraform FMT, right? And star.tf. Okay, means I will go here and I will take this path. I'll copy this and I'll put star.tf. So you see, now as I said, it says that the module EKS.tf has some problem, right? The other modules and things has been fixed, but the modules EKS.tf has some problem. So let's see the EKS.tf, and we can see definitely there is not a closing bracket here, right? We can see there is not a closing bracket here, right? This we have to anyways fix it out. Now, before we do this, right, here we have to worry about that how we have to create the access entries. The access entries which Amit has created, we also have to create those access entries, right? So to create the access entries, right, we'll define the access entries equal to and this. And now we're going to define the access entries that, okay, there will be one access entry with a policy associated, and that will be your cluster admin. Okay. So we define this as the cluster admin policy, right? And we will say that this is going to be my Kubernetes groups, and I will write the principal ARN for that, right? And that ARN will be, right? That ARN will be my role I'm going to define, whichever the role Amit has created, right? Or the user, right? So in this case, it will be ARN colon user EKS CLI user. So I will use this, and this will be my principal ARN. Now see, the code has been written in such a way that the account ID has to be fetched on its own, right? The account ID has to be fetched on its own. We don't have to go ahead and we don't have to create the account ID here. Remember? So this is important part here, right? This is the important part here to be noticed. Okay. Now we do have this. We have this. Now we'll create the policy associations, right? And so we have this all created. Now with this being created, right? We if we will we also have to create one Terraform user, right? For that, if we can do it from the GitHub actions and things. So we'll create one Terraform user, right? And for that, we'll create one Terraform role. So that we will create this, right? So let's say we'll create the SkillUpWithSachin, and we'll give this Terraform role, okay, for the user. And to that user, we'll define again the policy, whatever the policy is needed, right? So we will define that user policy too. So let's define the policy for the user. Now looks like there is all good. We have this EKS.tf. Let's say it should point out to the last. This is okay. This should point out to the policy access entries. So this is pointing to the access entries. This should point out to the Terraform user. This is pointing to Terraform user. Getting this, guys? Whatever the access entries you have to create, right? For each user, you will create a separate access entry. Okay? Clear? Hai? This part?
Yeah.
Okay, now I run my Terraform format again. And you see everything looks to be good. It has formatted everything, right? Now I can do also one more thing. I can do the TF. So remember in this Terragrunt.scl, I have to make some changes, right? Here I have to just make sure that everything is in alignment, right? So yes, everything is in alignment. Yes, subnet IDs I have to pass. Can you give me those two subnet IDs too, please?
Yeah.
And more than the subnet ID, I also have to create the account.scl. So let's say account name, I'm gonna give the admin, and I'm gonna give the account ID that I will take it from this role. So this will be my account name ID, right? Now also in this data.tf here, I have to define the value of the tag, right? Whatever the names I have created, right? So I have said that you give the name as a demo hyphen test, right? So here I will write demo hyphen test so that it will automatically pick up my value or the VPC ID based on the value, based on the tag. Remember?
Yeah.
We have defined the tag. So based on the tag, it should pick up the value. Okay. So based on that tag, it will automatically pick up the value. Now, further to this, we have the subnets. So let's say private or public, whatever the subnets, we will define this. So like you have defined private, can you define the type as public for a couple of them and keep T as a small? Okay. Yeah. In the subnets. So any questions here?
We have already defined type public subnets. Do you want me to define private subnets now?
Yes.
Okay. All the remaining 3 or just the 2?
Any two.
Okay.
So here now I have all the files, all the things has been done. Everything is good. Now I do have now I can run a validate, right? So it is asking that there is some exception. Okay, we can remove that. Terraform validate is not needed for now. In this Terragrunt.scl here, I need to pass on the ID, right? Here I need to pass on the ID too, right? So let's pass the IDs. Can I give me one more? And okay, I have one more now. I will use this and I will use this. So that means I do have all the IDs, I do have all the things with me. Subnet IDs I have the rows, I have the things, everything is good. Cool. Now let me push this code to the GitHub. Oh, but one thing is left, the workflows. Remember, the workflows are still left, right? Now, the workflows are still left because I need to create some workflows, right? I need to create some workflows here so that I can set up the Terraform, I can run this all and I can create the things, right? Now, here comes the challenging part where, so to run it via the CI/CD, right? We're gonna use pull request.yaml, right? And for this, we have to define that, okay, you have to validate these changes whenever anything is being pushed to the main branch, right? And if any changes has been made into the EKS modules, right? So we're gonna use the default uh, jobs, right? We're gonna use the default jobs and the things, and we have to, right? We have to make some connections. We have to do some write some steps, right? The steps will be what? It first step we have to check out the code. So this will be checking out the code for me. And once the code has been checked out, right? After that, I have to set up the Terraform environment. Now here comes the major challenge, right? So, however, let's use this, right? We will use in this way, and let's use this Terraform version. So let's use this version. Now the point is we need to define it this way. So once we have Terraform environment set up, we also need to set up the Terragrunt, right? We also need to set up the Terragrunt. So not this way, right? We will set up the Terragrunt. So yes, so we'll set up this Terragrunt and we'll use this 0.53.8 version of Terragrunt, for example. We're using a bit older version, but it's okay. Now we have defined the Terragrunt, we have defined this. Now the next step is to configure the AWS credentials. So we're gonna use this, right? And either we can configure this via the this way, that is the AWS auctions this, and we'll assume the role, right? Remember the role which we're gonna create, we have to give the ARN of that role, right? So it will be ARN colon AWS colon IAM colon the ID account ID is this, and we will be creating one role here, right? Role, and we'll give this role as a name as SkillUpWithSachin hyphen GH Terraform service role. and this we're gonna create in the US East 1. This is all done, right? Now we have to run Terragrunt plan, right? We have to run the Terragrunt plan, right? To run the Terragrunt plan, we're gonna create the working directory, right? Now our working directory will be what? Our working directory in this case will be environments dev, and in this will be my working directory, right? Environments dev SkillUpWithSachin EKS demo. Okay, I will run. Okay, whatever but don't install a user, but it's okay. It's just that I will make sure that it is going to run in the non-interactive mode. Now, once this is done, right, then that is all. It's done, right? Nothing else has to be done. So we don't want to this. We just want to use this cleanup actions, right? Which will basically clean the cache and the other things. This is all done here, right? Okay. Any questions here with this?
No, Sachin.
Likewise, we're gonna create the same configuration. We're gonna create the same things. It's just the things will bit change, and we will call this as a apply.yaml or deploy.yaml. Let's say, and we will create this as run Terragrunt apply, and here you wanna write Terragrunt apply, right? And you will just put that any approvals should come, it should go as a auto approve. That's it. This is the main change you want to do. Likewise, you want to create a destroy also, means the cluster has then be destroyed from the main module, right? It can be destroyed from the main module itself. So you don't need to perform, you don't need to do any other thing, you just need to do the destroy part, right? In the destroy part, we might want to take the cluster name from the user, right? We might want to create a cluster name from the user. So instead of this on pull request, we're gonna put the workflow dispatch, right? Which will basically help us to run the manual actions, right? Here you can run the inputs, you can run the cluster name. Okay, you can write the cluster name and you can write that description. And this you can put that EKS cluster name to destroy. Destroy. Right. Now, once you have done this, you say required :true. Right. That means this is the value. This you will change. This is going to be destroy. So this will be for destroy. This will be for deploy. So this job you will change to deploy, so that we have all the configurations put up here. Right. Now in the destroy here, you will make the change here to run Terragrunt destroy, right? And you're gonna use destroy, and rest all remains the same. Clear? This is how my entire end-to-end CI/CD for deploying the infrastructure will look like, right? I have created the CI/CD job which will do all the things. I have created all the stuff. Now I'm gonna do git add dot git commit -m updating infra code, and I will do git push origin main. Now you see what's gonna happen. So I will do this here in my GitHub repo. TF module AWS infra. Are you guys able to see my repo?
No, no.
This is my repo, right? And in this repo, all my code has been triggered. And if you see the actions, my action got failed. Okay, the action got failed by it says some syntactical errors. That is line number 18, column number 7. The step should be here actually. Okay, and then rest are the same. And this change will be on the everywhere. Because you saw here that as soon as the workflow syntax will be wrong, right? So you will not see the file name correctly. You will see the path only. Okay, in the GitHub actions. Getting it? This is the way to identify there is some syntax issue. Now I will fix it. I will say get commit minus n fixed syntax for the actions. We noticed that PR was failing due to some or other reason, right? And now what we will do, we'll follow the one of the standard practice that we will create one actions repository. I have created this actions repository where I have created this setup Terraform environment and setup Terragrunt environment. So setup Terraform environment was having what? It is having action.yaml workflow. Now I've given the name of the workflow name as a setup TFANV, the description of the workflow. Now, if you see, the difference between Jenkins and the GitHub Actions is not much, right? It's that you do the same in the Jenkins, just the syntactically things are different when you write in the declarative format or in a scripted pipeline. So that will start from your node and then you define your agents, scripts, and then steps, in each steps actions you put up. Likewise, here also you define the name description and then you define the runs that and the steps. In the steps, you define that what each step has to do. So if you see here, I have created the name, like I've written the name and the description of the workflow. This is the name which will be visible in this actions also if I put it in the GitHub workflows. Now, then I'm saying that we will use this composite action, means we are going to use this for setting up a Terraform, and we are cloning here the repository, right? Copying this into our current GitHub workspace. So this GitHub.workspace is a Git environment variable. Okay, this is a default Git environment variable which we are using here, and using this we are going to set up my Terraform environment here, and we are going to install the specific Terraform version. The Terraform version whichever we have to install, that we have already defined here in our repo as a .terraform version. Okay, we are installing a bit older version, but that is okay for now. Now, likewise, we are setting up Terragrunt, right? That you're gonna clone the Terragrunt environment. You're gonna add it into the GitHub path, and just update the permissions. Okay, and we're gonna add the Terragrunt version also here, right? Now, so this action repository has been created. Now we have to use this in our current workflows. So in my current workflows, what I have done, I have just written, let's say, this pull request, validate pull request. This means that anytime the pull request is created, okay, anytime the pull request is created, update this PR, right? Or or basically run this workflow. So you see that trigger action which is there, that is on pull request, where any pull request which is raised against main branch, and if any changes has been made under this EKS module path, okay, then only you have to trigger this. And it says that you have to perform the different actions and the jobs in the steps for validation part, means you are going to run it on a particular runner. Now, like in Jenkins, you used to have a node, right? You configure the EC2 node or you configure the Jenkins node, right? Jenkins, wherever it is running. So there itself, the jobs are running, correct? Likewise, here in GitHub, it provides the runners. Now, there are two types of GitHub runners, right? Or the, runners. where the first one is like the default runners which GitHub provides, right? Again, every cost is associated with everything at an enterprise level and with the usability. The another one is the self-hosted runners, means you can define your own runners also at a GitHub level. Okay, so that we will see at the end that where the runner is going to be defined or put up. So we are going to use this by default runner which GitHub provides. Okay, and we give some permission that it has to read and runner has to get the OIDC and things, because remember we have created the OIDC provider in the AWS. Now this is the steps we are going to create the check out the code. So this is the default actions checkout, right? This is not our actions checkout. Remember, this is the default GitHub actions repo. So if you search for GitHub actions repo here, right, you will see this is the GitHub actions, default GitHub actions repo, and here you can search for the checkout. You can see it provides the multiple ones. So this is a checkout one which I am using. And for this, it says whatever tags you want to use. So I am using version 4 here, right? So whatever the version you want to use, you can use from here. And if you want to go into detail that what all this action contains, you can use this action.yaml and you can see that it contains all these things and it needs input as a repository. And by default, it will take your github.repository and other things. So you can use that. However, we are saying that in this case, use the reference branch as a GitHub event pull request head reference branch. Means whatever my pull request branch is there, take that up. My next step is that as I have to run a Terraform and Terragrunt code, I have to set up those also, because this runner is what? This runner is a plain OS, right? It is a plain AMI, plain Ubuntu machine. So I don't have any other thing running in it, right? So I will be setting this up. To set this up, I have to call the module which I have already created. Where I have created that, I have created that in this SkillUpWithSachin organization. So in the actions repository and in the setup tfenb with main in the main branch. So when I will use this, it will by default reference this here, right? The action.yaml. By default, it will reference this part. Likewise for setup tgenv, I'm configuring the AWS credentials. I'm using it from the AWS Actions repository, and I'm using the this GitHub Terraform service role, okay, which we have already created. To run the plan, you run simple tf init and tf plan. So in this here, tg init and tg plan, when you run it with the Terragrant, you are using that, and you are going to configure the environment here, and you just run the entire thing. So this will completely run your Terragrant plan, okay. Likewise, once this plan is merged to main, you would like to apply the plan, right? So for that, we have to deploy Terraform changes, which will only and only trigger when there is some changes happening in this EKS repository and there is a push happening on a main branch. Okay, and there's a push happening on a main branch. And again, entire other things gonna remain same. We just run this tg apply, right? Instead of tg plan. Likewise, when you have to destroy the cluster, so here to destroy the cluster, it should come on a manual choice, right? That okay, I want to destroy the cluster. So in that case, I want to run this on a manually. When you want to run this on a manually, you will not define any other trigger action. You will define workflow dispatch. So this will take the thing, allow the things to run manually. See here in deploy also, I have both trigger action as well as I can trigger it manually also. Okay. Now when I use this, I'm going to use this input cluster name and things, and it's going to use the cluster name, and it will basically you pass your cluster name and it will take that cluster name as a value and it will destroy the cluster too. Okay. So cool. This is the whole setting. And remember, we forgot one thing to add, that is a parent terragrant.scl. So we have added this where we have defined this remote state, right? Where the TF state has to be created. And for this, we are following a standard that, okay, read the account variables. So what will happen that whenever Terragrant will run, right, it will run from this root folder. it will pick the things from this root folder. Okay, so in this root folder it will try to look for this account.scl, means for the account variables, that is account id and aws region, as we are using the same. And then it will generate the provider. So this will generate a provider file, right? Generate means generate a file with a name as a provider.tf. If it exists, overwrite that file and add the content. Okay, add the content in that file name as provider aws and pick the region from account variable. Pick the region from account variable. And also if there are any tags and those things, so it can take that way. For the remote state, we are creating this S3 bucket file where we are having this account ID as a, so bucket file name will be account ID hyphen tf hyphen state hyphen region, right? So these account ID, how it is picking up local dot account vars. Remember, account var is a variable in which all the variables for account.scl are getting stored now, right? So it will go to locals dot account vars dot account id. So this is dot account id dot aws region. This is dot aws region. So this is how it gonna refer to that, right? And your key will be like with the folder subfolder which will be created inside the bucket, that will be in this way. And then it just define this backend.tf file for the same. So these are the things which will be created during the workflow run. Now, as I already created one PR, so once I have created one PR with a, I have not done anything here in this PR. If you see, I've just added one dot, right? So that I can create the PR. Now, once this PR is created, so if you see this action, this has been triggered successfully. In this validate action, it has firstly set up the job, means it is trying to set up the job where you see it is using the particular runner version. It will update the runner, update the permissions and other things. Then it will check out the code. My another one, the another action or the step was what, to check out the code, right? So it has sync the repository, check out the code. See, this has done this, and my branch, it has taken the PR branch. Okay. Now it has set up the Terraform environment. So it is using this one, and with this, it is cloning the Git, and it is going to set up the Terraform environment. It is going to set up the Terragrunt. It is going to set up the configure AWS credentials using my assume role. Okay. With that, now it is going to run the Terraform plan, right? It will first run Terragrunt init so that Terragrunt is initialized, right? So it will initialize the Terragrunt. Once that is done, then it is going to start the Terraform plan. So with that, it has says that okay, initializing the backend, it is creating, so it has created the S3 bucket, right? Terraform state has been created. We are calling the module, remember that module, EKS module we were calling, so it will use that particular EKS module. Whatever the required dependency and providers are needed, it will install all those things. Means Terraform has been successfully initialized. And remember I said that it creates a .terraform.log.scl file. So this particular file will be created, okay, by the Terraform, the log file. After that, it will read each and every component that okay, we want to create a node group with the name as cluster name hyphen ek ng hyphen 1. So it will read that, right? It will basically read that whatever things we want to create, IAM policy, node group, right? It will read the current region and put all the values. And now it will start populating all the changes that okay, we want to install the EBS driver, right? We want to install the core DNS add-on, kube proxy, snapshot controller, VPC CNI, cluster admin, and everything, right? So it also creates an entry for this Terraform user which we have defined, right? So this will create each and everything for us here. Okay. Now with this, at the end, if you will see, it will tell you uh, how many changes are going to apply, right? So as it is going to here, everything is good. It says 22 has to be added, 0 to change and 0 to destroy. That means this is the end-to-end Terragrunt plan which is there, right? Any questions here?
No, Sachin.
Now I'm going to run the apply, right? I'm going to merge this one and I let's see if this applies anything. Okay, so yes, now you see my deploy Terraform already triggered, right? It triggered automatically. Okay, so if we will keep an eye on our EKS also, it should be doing some or other stuff. It should be, so now you see it started running Terragrant apply, right? Other steps gonna same. It has initialized successfully, and it will take some time to apply, right? And if you see this is starting to apply, and it is applying this, but this got failed here with some other changes. So it says that unsupported availability zone. Okay, okay. I think we have just made one mistake, which US East 1E is one of the availability zone which cluster does not support. So we have to put the subnet IDs with 1A, 1B, 1C, 1D. So if you can give me the subnet ID with 1A, 1B, 1C, please.
Yeah.
So we can put that. Let's do that. Okay, so here we have basically, just as we are getting subnet ID changes, we have just added the three subnets, okay, which are in a availability zone 1A, 1B, 1C. This is good learning that it does not support the subnet in 1E also. Now, once we have done that, what we have done that we are going to trigger this workflow again, right? We're going to trigger this from workflow main and let's see now this deploy Terraform changes. It is going to be triggered and in some time we're gonna monitor that, right? So ideally if all goes good, it's gonna create an EKS cluster for me and it will update the S3 bucket. So let's see the same. So Terraform has been initialized, right? Everything is good. Can we see the AWS screen now, please? So I'll switch to AWS screen now, and this is coming up. And yes, you have to see that this cluster is getting created. Okay, and if we click here, the cluster is getting created. Right, I have all the things coming up. Now, can we also see the S3 file? We should see the state. Yes, you see this is the file. You see this is the cluster, environment, dev, and this is my Terraform state. If you click here and if you click on download and if you try to open that file, you will see the details with respect to that file in the different things. You see the TF state first, Terraform version, the resource IDs, the names, the region which it is applying, right? And all the other options which are important here. So this is your end-to-end.tf state file, right? So yes, this overall it takes some time to create a cluster to put up the things, but meanwhile it will do, right? You can basically clone my changes, you can fork my repository, you can sync the fork if you have already forked, and I will give you the couple of readme actions. You can read the readme and you can using the TF module AWS infra using the actions repository, you can see that how we can create the EKS cluster, the end-to-end EKS cluster we can create on our own, right? Now in the next session, we will be talking on the how to spin up or how to provision the applications also on the same, right? How we can run the application on this. So we have once provisioned the infra and the things, how we can create the applications on it, and that applications will help us to run the show end to end. So that will basically be your end to end CI/CD deployment from provisioning of infra to everything. So this is how the things will be deployed. This is how the things will be in control. Now Um, so yeah, keep so let's see further that how this is going to be.